Hello everyone. So we are going to start the part A, that is the last part from the unit Micromeritics. So in this unit we are going to deal with some approaches to prevent the powder segregation and moreover the quality control of the powder. So without wasting any time, let's start the presentation. So what are the approaches to reduce or prevent the size segregation? So we have already discussed regarding the different parameters which affect the segregation. For example, the difference in the shape, the difference in the particle size as well as in their density. So now what are the approaches which can be used to reduce or prevent the segregation? You see, selection of a particular size fraction. So before using the powder for formulating any drug dosage form, we have to first of all select a particular size fraction. How we can do that? We can simply do that by sieving. We use the sieving process to remove the fines. Fines mean the fine particle, so that only we can use the granules for the compression of the drug, right? Actually, this sieving, it helps the drug and the excipient to get the same size, right? So this sieving, they will prevent or they will help to get a particular size of the drug and the excipient for further use, right? The next one, it is the size reduction. We can perform the size reduction if the size is more, but the thing is that excessive size reduction should be avoided in this practice, because if we do excessive size reduction, then production of fines may also take place, and which is actually not desired, right? Moreover, we can do controlled crystallization. So during the time of the production of the drug and excipient, we can do controlled crystallization to get the crystals of the drug and excipient of desired size and shape. Done. So you see, the selection of the excipient, those which you are going to use, that also need to be done in a proper way. You should always select the excipient of same density with that of the drug you are using for formulation. Means suppose for formulation of the drug, suppose we are using dosage form, we are using the paracetamol. We know the density of the paracetamol, right? So for excipient, if we use a similar excipient with the same density or similar density with that of the paracetamol, it will try to, at least it will help to remove the problem of difference in the density between the API as well as the excipient, right? The next one, it is the granulation of the powder mixture. So actually this is a very useful one. So the granulation, it helps in the size enlargement, right? We know that the granulation, it helps in the formation of the granules. So after mixing the powder drug with the excipient, we can make granules. The granulation process actually helps to reduce the unevenness in the sizes, means that the improper distribution of the sizes, right? So the thing is that the last approach, that is the reduce the extent to which the powder mass is subjected for vibration or movement after mixing. Means we should use such apparatus or such equipment which actually helps to reduce the extent of vibration that will be applied during the process of tablet production. For example, you can use fluidized bed dryer or high-speed mixer. This type of equipment generally immediately do the mixing, or they immediately form the granules, and which can be used for further compression, right? Now let's see the QC of powder, that is the quality control of powder. How we are going to perform the quality control of powder in the industry. What are the tests actually which are performed for quality control of the powder? Number one, it is the particle size and shape determination. For determining the particle size and shape, we can either go for sieving, we can go for sedimentation, microscopy, and light scattering, right? Now surface area, how we are going to determine? BET, BET, right? We have already discussed. Next method, it is the air permeability method. The next one, it is the density. For density, we are going to determine the bulk density, tap density, and the true density of the powder. Then you can see the granule density, its strength, and its friability. Again, we are going to see the flow properties. Flow properties, what are the flow properties of the powder? Angle of repose, compressibility index, Hausner ratio, right? This all thing will be evaluated. Then the moisture content of the powder will be evaluated. Finally, the percentage of fine. So the moisture content and the percentage of fine I am going to give you in details in the upcoming slides, right? Now the thing is that granule density and strength and friability, how you are going to determine. You see, granule density is nothing but it is the granule weight divided by granule volume. That is the granule density. So the granule density, it is determined by a classic method. It is known as the mercury displacement method. So here we are going to use the mercury, and the property of the mercury is that the mercury actually it enters the void between the granules. It will enter the void. The mercury will enter the void between the granules, but the mercury, they don't ever enter the pores of the particle. That is the plus point. That is the advantage, right? Thus we are going to use the mercury. So mercury, moreover, it has a non-weighting characteristic. So if we are using the mercury for determination of the granule density, you should not worry about the weighting characteristic of the solvent, because the mercury as a solvent we are using it, the mercury it is non-weighting, or it is non-weighting, it is having non-weighting characteristic. So the method similar to the true density determination, and for strength we are going to use the hardness tester. For friability we can use the friabilizer. Example I have given here. This is the simple friabilizer that is used in the laboratory scale also, right? The next thing is the moisture content. So regarding the moisture content, you see, what is moisture content? It is the amount of the moisture which is present in the granule. That is the moisture content, right? So the moisture content, it is generally in the range of 0 to 2%, not more than that, right? So why it is required? It is required, the moisture content is required for binding of the powder and the granules during the compression in the die cavity. In the die cavity means in the tablet punching machine. For binding we need the moisture, but the moisture should not, the amount of the moisture should not exceed the 2%. Now if somebody asks you how you are going to determine the moisture content, there is a simple method. The moisture content, it is determined by using the moisture balance, or you can say the IR balance. So what is the procedure? So IR balance, it consists of a simple balance, right? It containing the IR bulb. The IR bulb, it produces the heat inside the chamber. IR means the infrared, nothing. So what we are going to do, a small amount of the sample, that is the granule, that has to be placed in the IR balance. We are going to place the small amount of the sample in the IR balance, right? Weight the sample first. Earlier suppose it is 10 gram, right? Now the IR balance is operated at a specific time and a specific temperature, right? So you are going to start the balance. So the IR, from the IR balance, the IR bulb will emit heat. From this heat, the moisture will get evaporated. Then you get the final reading. Suppose you are getting the final reading as 8 gram. So the moisture content, it is equal to initial weight. That is, suppose we have got initial weight 10 gram minus final weight, suppose 8 gram, divided by initial weight, that is 10 gram, into 100, the whole into 100. That is the moisture content. Clear? So this is the IR, actually this is the equipment, IR balance, right? The next one, it is the percentage fines. Percentage fines means nothing but it is the amount of the fine particles which is present in the granules. So the fine indicates the particles of different, or you can say smaller particles which are present in the granules, right? So the thing is that the fine, they are actually necessary in the process of compression. You know why? The reason is that if we use 100% of the granules, suppose for compression of the tablet, we have made the granules, right? Now if we are using the 100% of the granules without any fines, what may happen? This granule will go to the die, it will be subjected for compression, but tablet will form, no doubt, tablet will form, but this tablet will have voids, and these voids will lead to formation of weak tablet. This tablet can be easily broken down. But if fines are present within the granules, what will happen? This fine will go in the intergranular spaces, or the intergranular spaces, or you can say the voids, so that you are going to get a compact powder you are going to get a compact powder. Just to replace the voids, we are going to use the fines, right? And if we use the fines, then definitely the tablet will be of a greater strength. Here, so the percentage of fines can be calculated by using the sieve method, right? So the thing is that you should keep in your mind that percentage of fines means the powder drug during the compression of the tablet, it should not exceed 15% of the total content, right? So that's all from this unit Micromeritics. Hope you like the video. Thank you everyone. If you like the video, just press the like icon. You can share this video and you can subscribe to my channel. Thank you once again.